Okay guys, good afternoon. Today we're going to look at Unit 3, the second lecture. So we're going to look at Chapter 11 and Innovation and Integration Clients as Drivers of Industry Improvements. So you will see the construction industry is a highly fragmented industry. And this chapter looks at the integration as a means for innovation. So getting all the people to talk to each other, that's basically what it says. It is in search of a lasting and sticky solution, and there are no stable supply chains and few strategic relationships in construction. If you think about your projects moving from one to the other, you often have a whole new set of role players that comes in each time. The traditional contract methods militate against sustained collaboration and supply chain integration. So that is basically the mindset that we've got in South Africa, that each time we go out on tender and we put a new team together, when the client wants the new design, he goes to an architect and he gets a team, and they start putting the project together. So coalitions between designers and contractors in the building team will lead naturally to integrated processes. Okay, the three important areas of innovation leading to construction processes is the integrated emerged in increasingly powerful trends in the industry, and then integrated project delivery, building modeling, and then supply chain. So these are the three areas that we're going to look at today. So in this chapter we'll look at the Dutch example of the collaborative explosion in 2013. Okay, so the theory of integration, the Integrated Design and Delivery Solutions group of the International Council of Research and Innovation in Building and Construction has produced a roadmap. Okay, guys, so this roadmap is very important for me, especially for the exams. You must be able to know what it is and must be able to discuss it, the items. In the next slide we'll have a look at it. But basically the goal of is a sector where people with traditional and new skills practice more collaborative and communicate processes supported by pervasive but nearly transparent knowledge and information based on technology. These professionals will be working towards continuous improvements across every phase and significant task on the project, conceptual planning, and making the business case. All parts of design, supply chain, construction, commissioning, operation, retrofit, and even decommissioning and capturing the lessons learned into subsequent projects. Okay, so this is now basically to persuade your people or the people on the project. Okay, and then we look at our figure 3, the imperatives, research areas and vision of the IDDS, integrated design structures. So this is the roadmap that I was talking about. So you must be able to discuss the training, knowledge, occupation, facilities, building information modeling, lean construction benefits, integrate the project delivery, where you have collaboration, interoperable technologies that you can actually use, integrated processes, and then in the middle you have your optimality. The vision is to minimize all forms of waste whilst delivering greater assured value for sustainable whole life cycle outcomes. Okay, so the drivers for this is the drivers for strategies for innovation diffusion is successful innovation entails both the development of new ideas, processes, or tools, as well as the take-up of that innovation throughout the industry. Innovation in the construction industry requires three components, namely idea generation, opportunity, and then diffusion. Okay, so the key factors that influence construction innovation in projects is the client, as we've seen it in our previous chapters, production structure, innovation networks, procurement systems, regulations, organizational resources, and the client acts as the catalyst to foster diffusion in innovation. They can also demand innovation. Very important. Okay, then the next diagram, winch model of innovation structures in the construction industry. Pretty straightforward diagram. You have your system integration, your principal architect, engineer, principal contractor, basically your project manager here. You've got your regulations that he has to adhere to. You have his client's input. He has the professional institutions. Then he has components, the material supplier, and then he has the trade contractors, and then the special consultants that assist him. And this is the guy that actually evaluates whether the innovation is worthwhile implementing or not. Okay, now we get to our framework of analysis. Now this is very important. You must be able to do this framework analysis of a given example. So for instance, you have your superstructure, which entails your client, regulations, knowledge, and institutions. Infrastructure is your trade contractors and suppliers, and then you have your system integration, building firms, architects, etc. Okay, so your integrated project delivery. Now we're looking at that example that I spoke about earlier, and the Dutch government building agency, DGBA. Oh, sorry, DBFA, FM, first design, build, finance, maintain project, DBFM, the renovation of the Ministry of Finance building in The Hague, went to the market in 2005. The use of an integrated project for that job achieved a cost saving of about 15% compared with the traditional call for tenders. The renovation work began early in 2007, and the building reopened at the end of 2008, 2 months ahead of schedule. Okay, so obviously this was a successful project that they had here. Okay, so this is just a couple of photos of that. You can see it's in Europe, so glass is always in abundance. Okay, so what can we learn from here? Okay, so we take our project delivery, integrated project delivery table, and we look at what was our superstructure client, regulations, and knowledge institutions that was used. So your innovation diffusion strategy, consistent procurement of projects in this project, development of information structure and materials, uniting organizations involved, setting up clear and straightforward communication, development of supporting instruments such as standard terms and contracts, setting up communities of practice sharing information. Infrastructure, trade contractors, suppliers, okay, not involved here. And then system integrations, you had setting up knowledge sharing networks and setting up internal knowledge centers of project and private partner projects. Okay, and then setting up new legal entities to limit risks. Okay, that's the one system that was used. Then the next one is BIM, which you guys are very much aware. So the principles behind BIM were known already in the 1970s. It was too expensive at the beginning, only really started taking off in 2006. Today it still remains a largely emergent idea. The market pool is a major contributor to its use. Okay, so that's just a bit of background. But let's evaluate building modeling. Information modeling. So the superstructure is setting up your client's regulation knowledge institutions. So it's setting up means to share knowledge, development of supporting instruments such as standard exchange formats, legal applications of using BIM, setting communities up for of practice, sharing information, receiving major clients who ask for the use of BIM, developing new integrated processes as forms of collaboration through the chain. Okay, so infrastructure, trade contractors, suppliers, standardizing supply of data of their products in 3D software. Okay, so BIM doesn't replace the procurement method. So the previous one that we looked at, the contractors were already on board during the procurement process. Then the system integrators, starting with small pilots with reduced BIM functionality, developing and sharing knowledge and experience on BIM together in communities of practices, and then emerging of multi-project collaboration between these parties. Okay, so you can see BIM is a little bit more flexible, and the procurement method, you can still use it on the traditional method or on the early contractor involvement. Okay, and then I just added the different levels of BIM. We have level 1, which is basically our CAD, level 1, which we basically know, so this goes up to the architect, which produces 3D models and uses different software, file-based collaboration. Level 2 BIM is where everyone basically starts using BIM, and it goes up to a level where all the consultants share the BIM information in a virtual environment. IBIM, or level 3, is where the total lifecycle management is managed, from the design up to the actual maintenance of the building. So please remember that level 1, 2, and 3 does not refer to 2D and 3D. It refers to the levels of integration and sharing of information, basically going from paper-based to paperless. Okay, then supply chain integration. This is our last item. Is a strategic relationship with designers, subcontractors, and suppliers that lasts longer than the duration of one particular project. Participants have shown they are prepared to invest in each other's processes. Participants have shown they are prepared to invest in each other's processes. Okay, and then it's basically the contractor gives feedback to the supplier of, for instance, materials, specialist installations, and vice versa. They build on each other. So you have a sector involved in management organizations, property development, architects, local authorities, schools, care institutions, and businesses, all working basically together to integrate the building system. Okay, so now you can see this superstructure is receiving clients' requests for productivity in sequential projects, starting with pilot projects, engaging in knowledge sharing projects also with building firms. Infrastructure trade contractors, this is a little bit outside the trade contractors portfolio. This is usually new novel installations, same as with our first example. Okay, system integrators, you've got making joint developments, knowledge sharing products, starting with pilot projects and gain experience, then share and it is combined. Okay, then the conclusion, client organizations are in the best position to take the lead in the integration. Innovation scores low on Rogers' 5 factors of influencing and adopting, and thus it may diffuse slowly until the particular demand is created for it. Remember that in construction there's usually higher risks, so that is why innovation is moving slowly. Client demands justifies further research in this sector, and then research in the performance of the client's demands. Okay, thanks guys, that's in a nutshell chapter 11. So we looked at the 3 different methods, and then we had to evaluate them. In the exam I might give you an example, and then you need to evaluate them against those 3 parameters as discussed. Thanks.